Hello everyone. Hello,
Hello
Cyril.
everyone.
Hi, just a second. Um, so I'll go ahead and introduce. First of all, hello everyone, and welcome to this is Learning Conference Day 2. I'm Meenal Jain, and this is the Cloud and Backend track. And our first speaker will be Cyril Marpot. And Cyril, I think that you will be talking about use embassy and the implementation of Snake for microbit, right?
Yes, exactly. I'm going to talk about
Okay.
email trust today.
Okay, besides the title, do you want to share any little bit more detail about it? Just a brief.
Yeah, sure. It's about embedded Rust using the Embassy asynchronous framework for embedded systems. It's an ecosystem, so I hope it'll interest everyone here. Um,
Yeah.
would you like to say anything else before I start?
No, you can go ahead. The screen is yours.
Okay, great. So
All right.
thank you everyone for your attention. Today, as I said, I'll be talking about embedded Rust on the BBC microbit using the Embassy asynchronous framework. So my name is Cyril Marco, and I'm an embedded systems engineer from France. And I hope this talk interests you. And let's begin. So a quick overview. I'm going to talk a bit about the hardware I developed this project on, which is a microbit, a small embedded board. Then I'm gonna talk about the software architecture. How did I design the Snake game on that board? And then I'm gonna show you the actual code, the actual modules, and we're gonna dive into the source code, the Rust source code. So first of all, I'm going to talk about the hardware. So as I said, it's designed on a BBC microbit, which is a half credit card size embedded board. It's the V2 of the board. There's also an older V1. The board features several sensors, like an accelerometer, a compass, touch sensors, buttons, a microphone, speaker, a LED matrix, and many GPIOs to do whatever you'd like to do with them. The board has been designed with educational purpose in mind, like educating children to learn them to code. And there are many languages you can program the board with, like Free Pascal, Simulink, Forth, Lisp, Ada, Swift, Basic, C, C++, and now Rust, Python also. And I'd like to show you how to do that in Rust today. But first, I'm going to talk about the MCU. What's an MCU? It's the microcontroller unit. It's an equivalent to the CPUs we can find in our desktop and laptops, general purpose desktop and laptops, except that those components, MCUs, are way more specialized for low-level tasks. They're way closer to the hardware than CPUs. So they're designed for embedded applications. The one on this board is called the NRF52833. It's clocked at 64 megahertz, so it's way lower than our usual CPUs. It's a 32-bit ARM architecture. It features 512 flash memory and 128 kilobytes of RAM, which is not much, but it's largely enough for our purpose. And the MCU, the component itself, which I'm not sure you can see it, but it's here on the board, also features a temperature sensor and Bluetooth and radio capabilities, which we're not going to use today. But if you want to communicate over the radio, you can do so with this microcontroller. So how do we get a program onto this board? Well, the easiest way today is to use the probe.rs library, which is a library that allows you to interface with MCUs, various and numerous MCUs, through debug probes. There are a wide range of targets that are supported, which can be found on the main page project. As you can see here, I can scroll quite a lot. I'm going to go to the end of the page and I can find the NRF52833 here. If I click on it, I have a description of the memory layout of the device. So there are many supported targets, and all you have to do to flash that target is inside the Rust project, you have to configure Cargo, which is the package manager of the Rust language, to use ProgRS to flash that chip. So if I look at the config file here in the .cargo folder, I have one line, which is runner, configured to run the ProgRS run command to flash the program on the NRF 52833 chip. And that's it. How do you run a Rust project? Usually you run the cargo run command. With that one-liner config set, you just have to run cargo run the exact same way, and it's going to flash the device. So the only thing I have to do now that this is configured is in a console, run the cargo run command. And I have two things to do. First, I have to plug the board in, and once the board is plugged, the power LED is on. This time, cargo run should erase the chip and then program the chip. It's pretty quick. And now the program is actually running on the board, and it's blinking. It's kind of hard to see here because of my camera, but there's a blinking arrow on the board. So that's it. This is how you flash a program on such a device, a target. You can also use, there are other tools. You can also use Cargo Embed, which is built upon ProgRS. And it's pretty handy. It integrates well in the Cargo ecosystem, but we are not going to use it for the purpose of this project. So now that we have talked about hardware, I'm going to talk more about software architecture. The first thing I want to talk about is what is it like to program for this target? It's an embedded target, and what we usually say is that we go bare metal. It's a bare metal target, meaning there is no operating system, there is no kernel like the Linux or the Windows kernel running on the target. The only thing that is running on this target is the binary, the program I flashed onto it earlier. So we're in no STD mode for no standard library. What does this mean? It means that when you compile the program, you actually link to the core crate instead of the STD crate. What's the core crate? So docs.rs/core docs.rs/core. Zoom a bit. The core crate is the dependency-free. It's the only dependency-free crate of the Rust ecosystem. Foundation of the Rust standard library. It's the portable glue between the language and its library. So it's the bare minimum you need to program in Rust. What is there in the core crate? Well, floating point numbers, integers, tuples, unsigned integers, etc. A few modules, macros also, but not much apart from that. It's the bare minimum. So when you go in no STD mode, what you actually do is you do not use the STD crate, you use the core crate instead. A consequence of that is that you don't have an allocator. The standard library provides an allocator, but the core crate does not. What is an allocator and what is it useful to? Well, when you use structures like vectors and strings and stuff like that, extensible collections, you need an allocator to ask for more memory to the kernel, the system. If the structure is full, you ask for more memory, then you make it bigger, you extend it, and then you can put more stuff inside. When you have no allocator, you can do stuff like that. This is why the core crate here does not provide structures like vec or string or any collection, any extensible collection. But there are replacements, like the heapless crate. What's the heapless crate? It's a library that provides similar structures, but that can work without an allocator. For instance, the vec structure here, I'm gonna go to the vec structure in the standard library. So what's a vector in Rust? It's a structure, a collection of items of a type T, generic. You can put whatever you like inside a vector. And there is a second generic type, which is the A type for allocator. In heapless, a vector, if I go to the structs vec structure, it's also generic over a T. You can put whatever you like inside as well. But the second argument is not an allocator anymore. It's a constant n, which is the size of the vector. So how do you declare a heapless vector? The exact same way, except that you give it a maximum size, and then you can push inside the vector the exact same way. So there are replacements to what you can find in the standard library crates, in various crates. Heapless is one of them, Ryu is another. And once you have these tools, you can begin programming on embedded targets. So the project is to realize a snake on the BBC microbit. Breaking new ground, nope. I'm not the first developer to think of developing a snake game on this board. If you go to this repo, you can see here that some other developer had the same idea before I did. I can show you the code in source bin like snake.rs. Here, zoom a bit. So I'm gonna describe the software layers that this project uses to get you up to speed with how do we program embedded systems. So this code is pretty. I'm not gonna go into details here. What I want to show you is the use statements here are in Rust used to import stuff into scope. And he uses the heapless crate as well. But there are three crates, NRF51, NRF51 HAL, and microbit that are used. The NRF51 crate is what we call a PAC, a peripheral access crate. And what this crate does is it gives access to memory mapped registers, meaning what's an MCU? An MCU is a computer that has peripherals, and to configure those peripherals, you have to write values inside registers, specific registers at specific addresses. And when you write the right values inside those registers, you configure the peripherals. This is by nature unsafe because you have to write values at random, not random, but arbitrary memory addresses. And the compiler has no way to know that these pointers, these addresses are valid. So this is unsafe by nature. So what a peripheral access crate does is it provides you an interface to configure the peripherals without having to write those values yourself. So it's just an interface, a low-level interface to configure the peripherals of the microcontroller. Then up one layer, you have the HAL, the hardware abstraction layer, which in this code is the NRF51 HAL. This crate, this library, is specific to a given microcontroller. So what the hardware abstraction layer does is it provides you a higher level interface to the peripherals in the MCU so that you can use them more easier. For instance, you can have several communication buses like I2C or SPI or whatever. And what you'd like is just to send or receive data from or to this bus. And it's way easier using the HAL than the PAC because the HAL provides you with a handy interface to do so. So this is the second layer, which is specific to the MCU. And upon this layer, there's a third layer, which is called the BSP, Board Support Package. The BSP is kind of like the HAL, but inside the BSP, you find what's related to the board, not the MCU. For instance, on the microbit here, the LEDs are not directly inside the MCUs. The push buttons are not inside the MCU. They are connected to the MCU, but they're not inside the MCU. So these components should not be handled with inside the hardware abstraction layer, but inside the board support package. So this is why this is what a BSP is. It kind of describes the connections between the MCU and the board itself. So why redo a snake, although it's already been written? For three reasons. Main reason is safety. As I said, a PAC is by nature unsafe. And if you scroll a bit inside this code, you can see here there is the unsafe keyword, which in Rust is used to to show the unsafe parts of the code. And here he uses the unsafe word, and I think he uses it a little more. Yeah, here there is unsafe, unsafe also. So the first reason is I'd like to not use the unsafe keyword because we can do without it. The second reason is power efficiency. What we can see if we observe this code is that it's a blocking paradigm, meaning none of these functions are asynchronous. So you only go to the next line when the current line has finished executing, meaning the program is always blocking on the current line. So it's always executing something and never going to sleep. When using the asynchronous paradigm, you can do better. I'll talk about that a little later when you dive into the code. So the second reason is power efficiency, using the asynchronous paradigm to send the MCU automatically to sleep when we can. And the first reason, of course, is educational, because it's fun, because it's my hobby. And I'm going to use the Embassy framework in this project. So what's the Embassy framework? It's an ecosystem for embedded applications that provides a few crates, a few libraries, which are tools to develop on embedded systems. The first of those tools is an async executor, which is a runtime that decides which task is to be executed at any given time. You have also tools like future handling tools. Future is like a promise in JavaScript. It's an abstraction over the fact that a task can be pending, meaning it's not finished executing, or ready, meaning it has finished executing and the result of the computation is available. And you also have synchronization primitives like mutex, channel, signal, these kind of things. When you want to share data between tasks, you also have hardware abstraction layers, which are specific to a few families of microcontrollers like NRF, STM, RP. You can also provide your own hardware abstraction layer if you have one. You can, for instance, use the Espressif's ESP HAL on their components. You also have a time driver, network stack. You can do pretty neat things with that crate, like IPv4, v6, Ethernet, TCP, UDP, DNS, DHCP, etc. You can transform your device into your microcontroller into a USB device. You can use Bluetooth for the NRF microcontrollers. There are facilities to handle bootloader and firmware update related operations. And the framework is also real-time ready for those of you who work with embedded systems. This is pretty handy. So this is what Embassy is. It allows us to do embedded systems development in an asynchronous way. So now I'm going to dive into the code. The whole code is available in my GitLab repo. If you want to take a look by yourself here, it's available on GitLab. So the first thing I want to talk about is the display task. How do we display an image on that 5x5 LED matrix? Well, the first thing is to know is that each row and each column of the matrix is associated with a pin, a hardware pin that you can set to the high state or to the low states, depending on whether you want to turn a LED on or off. So first, you're gonna you have to retrieve the pins, map them as outputs, so that you can drive them. Then wait for an image to be signaled, meaning for an image to be for someone to ask to display an image, and then we're going to process the image line by line. What does it look like in the code? Display.rs here. So the file is less than 40 lines. There is a single function which is called task here. It's annotated with the Embassy task attribute. It's an asynchronous function. And it takes two arguments, the row pins and the column pins, which are arrays of pins. So the first thing we do is transform those hardware pins into outputs using the map function. So once the output structure here is just a driver that allow us to drive high or low any given pin. Once we have those outputs, we wait for an image to be signaled, meaning we don't do anything until there is an image to be displayed, to be actually displayed. And then we declare a ticker. A ticker is a structure that's going to tick at regular intervals. The ticker is going to tick at a frequency of 60 times image length, meaning 60 hertz times the length of an image, because we're going to display it line by line for electrical reasons. And once we have our outputs and our ticker, we're going to loop over those row pins. And for each column that has to be turned on, we set it low, and we set the row high. Having a column low and a row high is the only combination that will get a given LED turned on for electric reasons, specifically on that board. This is how they're connected to the microcontroller. So once we have turned the right LEDs on, we wait for one tick, and then we turn those LEDs off, and we move over to the next iteration of the loop. Just before moving to the next iteration, we check the image signal to see if a new image has been signaled, if someone wants to display a new image. When that's the case, we update the image variable, and then we break out of the loop, of the for loop, and we begin the displaying of a new image from the start. So this is how the display works. Get the pins, transform them into outputs, wait for an image, and then display them line by line. Now, how do we control the snake? Well, there are a few buttons on the board, 2 push buttons and a touch button in the middle. So we're going to use the touch button to start a game, and the A and B buttons to make the snake turn left and right. So the touch will use a signal, just like the display task uses an image signal. And A and B are going to use a channel. A channel is the exact same thing as a signal, except that it can store several values. A signal can only store one single value. And also, we're going to need to debounce the buttons. I'm going to talk about it in a second. So how do we handle the controls? Here in the control.rs file, we declare a channel, a signal, an enum, which has the 2 buttons. Pretty simple. And then we also have a single function, which is also called task, annotated with the embassy task attribute. So to this task, we give the 3 pins associated with button A, button B, and the touch button. We transform those into inputs this time, because we want to get the values, not set them. We want to know when the buttons are pressed, when we don't want to set their value. And then we're going to loop over a select function. The select function is going to wait for either of these 3 events to happen. So button A, button B, and touch, falling edge, meaning the button is pressed. And we await on those futures. And once one of them completes, meaning one button has been pushed, then we execute an action depending on which one of them has been pushed. If it's the first, if the button A has been pressed, then we send the button A into the button channel. If the button B has been pushed, we send the button B into the corresponding channel. And if the touch button has been pushed, we signal the touch button has been pushed. That's all. The only thing we have to do is to debounce the buttons, because the signal, the electrical signal at the pin level is not clean at all. It's very dirty, and we have to wait for it to stabilize before we wait for the next event, if we don't want to see several push events. So this is why we wait for 200 milliseconds here. There are better ways to do this, but this way is very simple, and it's fine on this project. So this is how we handle the controls. Now, how do we handle the actual game? Well, I have a structure which is called game with a method called play. And the play method handles three states: wait, ongoing, and over. In the wait state, we just blink an arrow. And then when the button is pressed, we display a countdown. The ongoing state handles the actual game, the moving of the snake, and the fact that it eats the food, generates new food when the old one is eaten. And then the overstate, where we display a happy face or a sad face depending on the fact that the player won or lost the game. How do we handle the game? So here we have a little more lines, 130. So the task, the main task, we just instantiate a game. And then we loop over the play method, which is pretty simple: waiting state, ongoing state, and overstate. And in each state, we do what we have to do, what I just described here, the three states. And then how do we bring all those elements together? I'm going to show you the main, which is pretty simple, and it's going to conclude this talk. There is a single function, main, a synchronous function. The first thing we do is initialize the board, the MCU, and the peripherals, providing the default configuration, which is fine for this project. And then I spawn the control task, giving it the button A, button B, and touch pins, which are here P014, P023, and P104. When I gather these in a tuple and I give them to the control task, which I then spawn, and I do the exact same thing for the display task. The display task takes rows and columns, which I gather here and here, and I just spawn it likewise. I also have a sound task, which I added pretty recently. I did not present it because there is no time. But the principle is the exact same, and the principle is the exact same for the game task, which takes an RNG, random number generator, to handle the placement of the new food when it's been eaten, so that it's random. And when the game task, once the game task has this RNG, I just spawn it the exact same way that I spawned the other tasks. So that's it. Yeah. Last time I gave that talk, it was in a room with people, so they had the opportunity to actually play on the board and to ask questions. Thank you anyway for your attention. I hope this was interesting and not too fast. And and that's it for me today.
Great talk. Do we have any questions from the audience? We'll wait for 1 or 2 minutes if there are.
Oh.
Okay. Nope, I think this is it then.
Okay, we're good.
Yeah, I think so. Do you want to share anything else?
Not particularly. I wanted to say thank you for the invitation. I'm very glad I could make this give this talk, and thank you everyone for your attention.
Yeah, thank you. Thank you for joining in, Cyril. Okay. Next, I think we have Sushrit. I'm gonna add him. Sushrit, can you hear me? Hey, hi.
Hello.
Yeah, you're audible. You can hear me, right?
Yes, I can hear you. How are you doing?
I'm doing good. How are you?
Thank you. I'm doing well as well.
Okay. So I see that you will be talking on the lessons learned from building a serverless notification system, right?
Yes.
Okay, go ahead. The screen is yours. Let me know I'm backstage if you need any help with the screen sharing. Yeah.
Sure.
All right.
I hope my screen is visible. Yeah. Okay. Hello, everyone, and welcome to the TIL Conf, and thank you for joining us today. So today's session is about what are the various lessons that I learned while building a serverless notification system. A bit about me. I'm Srushit Repakula. I'm an AWS serverless hero. I work as the head of engineering at Conf, and I'm also a serverless consultant. I do a bit of community work. I'm the lead of AWS user group in Tirupati here in India, and I'm also a co-organizer of the serverless group, one of the largest serverless groups across the globe. So the agenda for today is I'll be talking about what did we try to solve, how did we solve it, and why did we choose serverless? What are the problems, challenges encountered, and how did we solve them? And a few more challenges that we are yet to, kind of solve and complete the entire thing that we started. So, what exactly did we try to solve? So we wanted to build a highly scalable notification system that can deliver notifications to hundreds and thousands of recipients. It can be either via email, via SMS, via WhatsApp, and in the future, probably for mobile notifications as well, in app notifications. And what we wanted to also make sure that people can launch campaigns on our platform. So basically, this entire story is about how we built this for our platform called Confub. So I mean, this is a platform that where you all have registered for the event. While registering, you would have received an email from confub.com. So that is a platform that I'm talking about. So how we build. So as a part of an event ticketing platform, one of the important features is the ability of the platform where organizers can easily send notifications to all the participants and the attendees. As I mentioned, it can be all three modes of or three channels: email, SMS, or WhatsApp. Now, apart from the ability to send a campaign or launch a campaign immediately, we also wanted to have the capability to schedule a campaign where they can just schedule it and it'll be sent at the scheduled time. We also wanted to make sure that it handles duplicates so that no particular recipient receives the same content twice, because nobody likes receiving or getting spammed with the same thing again and again, right? So in a particular campaign, we wanted to make sure that there are no duplicates, even if the same participant has registered multiple times. And on top of it, the most important thing is the real-time analytics on the deliverability, open rates, click rates, and all kinds of analytics. Because what is the point of sending your campaigns if you don't know how it is behaving or how it's converting, right? So analytics is an important factor to consider. So in this session, I'll be talking about all these aspects on how we built it. So on a high level, what is the architecture that we use for this entire service? So the entire service is built on AWS. So you will see all of the services here are on AWS. So as you can see here, there are multiple services. All of them are serverless. I'll be talking about why we chose serverless as well. Of course, I'm a serverless hero, so it's obvious that I would prefer serverless. But having said that, I'll also be talking about a few of the advantages if, again, you are someone who's not familiar with serverless yet, right? So so here are a few components. So we have API gateway for creating APIs. We have Amazon Cognito for authentication and authorization. We have AWS Lambda, which is the compute service on AWS. We have SQS, a queuing service, another Lambda function. Event Bridge, we'll be talking about Event Bridge in a bit. And then we have a couple of data sources, Amazon Aurora and Amazon DynamoDB. One is a SQL database and the other one is a NoSQL database. Then we have the notification types, SNS and SES. So SES will be used for sending emails. SNS is used for sending notifications like SMS. And for WhatsApp, we would directly connect to the Meta APIs. So on a very high level, this is the architecture, and we will be trying to understand what are the various aspects that we took into consideration while building this architecture, and also some of the trade-offs, architectural decisions, and a lot more as we go along. So yeah, here are the various services that were used as a part of the architecture. Now, your first question might be, why serverless, right? I have kind of already given the answer. I'm a serverless hero, so I'm kind of always biased towards the technology. But keeping that bias aside, as an architect, you do not have anything of your favorites. You always have to keep in mind the problem and try to solve the problem without any bias, right? So for people who are not familiar with serverless or not have played around with it, a brief introduction of why serverless or what is serverless. So serverless is basically basically, in very simple terms, if I have to put it, it is a technology that helps you write code and execute code without having to think about any infrastructure or any kind of other things apart from your code, on a very simple and easy terms, right? So as developers, as engineers, what is our primary goal? We have to make sure that we solve real world business problems, right? And how do we do that? By writing code. So serverless enables us to focus on what is our goal, which is to just write code, right? And a little bit of a few advantages of going with serverless is, of course, there are no servers. I'm sure for people who know about serverless, they would have heard about it quite a lot right now, by now, which is basically there are servers, but it is just that you don't have to manage them anymore. So it is just out of your hands. AWS or any cloud provider for this matter will take care of it. You just sit back, write code, and upload your code into the cloud provider, AWS in this case. Configuration less scaling. One of the biggest reasons or pushing factors for going to serverless is the scalability. So we don't have to worry about the scale, neither scaling up nor scaling down. So as and when the requests come in, AWS will make sure that will make sure that the Lambda functions are available, the execution environment is available for your code to be executed depending on the number of requests that is coming in. So essentially what it means is that even if there is one request that is coming in or hundreds and thousands of requests that is coming in, you don't really have to worry about the scale. AWS will take care of it. Of course, there's a terms and conditions applied here, because I'll be talking about a few of those as well. So, why terms and conditions applied is because, as with any cloud service out there, there are limits, there are throttling limits and everything. So you'll have to keep that in mind. There are some quotas for your application, so for your AWS application. So you might have to increase it depending on your application's requirement. We'll be touching upon the throttling in just a bit. The next biggest advantage of going with serverless is the cost factor. So with serverless, you only pay for how much you consume, so which is essentially pay as you go. So if nobody is coming to your application, nobody is consuming it, you essentially don't pay anything. And as and when there's scale, you pay for that much amount of scale as well. And then built-in fault tolerance. So AWS takes care of making sure that there's built-in fault tolerance, and you don't have to change too much of your code if you already have a piece of code to get it to Lambda function. Again, terms and conditions applied here, because there are certain patterns and certain nuances of building serverless applications that you will have to understand before you actually build serverless applications. So although you can kind of bring in your code, but there are certain aspects of the code that you will have to keep in mind before you consume it. Now, with the introduction done, so what are the various problems, high-level problems, the important problems and challenges that we faced, and how did we solve them? Whenever we talk, and I will try and predominantly focus on emails, although it kind of applies to different channels as well, for the ease of understanding and delivering the session. I'll just focus on emails. And therefore, the first and foremost, whenever you're trying to send emails, especially in bulk, comes is the deliverability of the emails and the domain reputation. So it is important to understand here that whenever you're trying to send a huge number of emails from your application, different service providers like Gmail, Yahoo, and all sorts of other email providers keep a track of the reputation of your domain and also keeps a track of the reputation of the IP address from which the emails are being triggered. So if these service providers, like for example Gmail, sees that from a particular IP address there's a sudden burst of emails coming into Gmail, then it kind of becomes a little more cautious, thinking about, okay, is someone trying to spam or someone just blasting to a huge number of recipients? Because for Gmail, or from a Gmail's perspective, it's responsibility to safeguard the recipient's inbox from spamming and all sorts of things. So that is where the deliverability of emails and domain reputation becomes very important, especially for products or platforms like us, where there are hundreds of organizers who are using the platform and they're trying to send emails, which where we do not have any control of the kind of emails that are being sent there. And every organizer wants to make sure that their emails land in inbox, not in updates or in spam or in junk folder, right? So that is where this becomes very critical. The next thing is SQS, one of the services that I've talked about. FIFO queue was a standard queue. We'll be talking about the architectural decisions that we took over there. Throttling limits, I covered about mentioning that there are throttling limits in every single place. So how did we overcome that? The scalability, cost, and the time to finish campaigns. Now consider a case where an organizer is launching a campaign for 10,000 participants, right? We have to make sure that the emails go as early as possible, and it should not take like an hour for the emails to go. So how did we overcome that? Lambda functions max timeout of 15 minutes. For people who have worked with AWS Lambda, you would know that Lambda function has a maximum timeout of 15 minutes. And then the last, as I mentioned, we also wanted to have the capability of scheduling campaigns to the minute. So let's say, for example, from the platform, you want to schedule a campaign for 11:33 a.m., you should be able to do that. So how did we achieve that? The first problem how did we solve it is the deliverability of emails and domain reputation. So when you're trying to set up an email, be it any provider, MailChimp or SendGrid or any kind of email providers out there, you will see that there are two options. One is the dedicated IP and the other one is the shared IP. As you can see here in the diagram and the explanation, a shared IP, which is the default setting everywhere, what it means is that multiple customers of or multiple consumers of the particular product share the same IP address. That means, let's say you and I are using SES at the emailing service on AWS, and the default setting is a shared IP. So our region might share the same IP address for the emails that you send and for the emails that I send. So what is the problem with this? The problem is that if you send emails that are spammy or junk, it can impact the emails that I am sending, because both of our emails are being sent from the shared IP address. So how did we overcome from this? Almost all email providers out there, including Amazon's AWS's SES, has a feature called as the dedicated IP. So what happens, again, coming to SES perspective, is in SES you can create something called as a dedicated IP pool, where AWS will assign dedicated IP addresses just for your AWS account, and only those IP addresses will be used for sending the email addresses. This way, I am solely responsible for the reputation of my IP addresses. Therefore, someone else cannot really impact my IP address. So there are three types of options that is available on SES: standard, managed, and bring your own IP addresses. So with standard, what happens is it basically is a dedicated pool of IP addresses where we as developers or people consuming the service have to take care of warming up the IPs and scaling them out as well. Whereas managed is, as the name suggests, it's completely managed by AWS, where the dedicated IPs are generated by AWS, and AWS takes care of warming up and scaling them depending on the request that is coming into the application. Bring your own IP addresses is, as it says, where if you have an IP address that you have built in-house and there's a reputation that is created, you're just moving to AWS so that you can leverage. So excuse me, you can leverage the scalability of AWS, the elasticity of AWS. Then you can bring your own IP address. Therefore, the reputation doesn't have to be built again for the IP address. It is already there, and you just resume it from there. So what we have done is we chose the managed service so that the IP addresses are automatically managed by AWS and we don't have to worry about it. This way, we have managed to keep our IP addresses clean and safe from other consumers. The second problem that I talked about is the architectural decision between SQS's FIFO queue and the standard queue, right? So what exactly is a FIFO queue or a standard queue? So SQS is a queuing service which provides two options, standard and FIFO. As I mean, everybody knows what is FIFO. So basically, what comes first come, first out. So whatever message that comes first in the queue is what goes out as well, right? So the first comes out, first one comes in and the first goes out, like that, in the same order. Whereas in standard queues, there is no order guaranteed by AWS, and you can just dump in a bunch of messages and they are batched if you want to batch them, and they are consumed in no specific order. So AWS does not guarantee any order, as you can see in the diagram here. So what was the case for FIFO queues, right? I mean, you might think about it and say, yeah, FIFO queues make sense because I kind of have 100 participants and I have to send emails to 100 participants, right? So I can just use a FIFO queue so that they are sent out in an order. True. And the other advantage of FIFO queue is that it can handle duplicates and, of course, maintain the order, right? So that comes out of the box. Easier to understand the status of the campaign. Now, if you think about it, if there are 100 messages and you're processing them in an order, you know when the campaign gets completed, because after the 100th message is processed, the campaign is over. Whereas in a standard queue, you do not have an order. So you cannot say that once my 100th message is completed, my campaign is also completed. So there's a little bit of challenge where FIFO helps in making sure that because they are ordered, you can relatively easily understand the status of a particular campaign. And a few numbers. So with respect to the throughput, I talked about throttling, limits, and quota just a few seconds ago. So this is what it is. Unbatched throughput is 300 messages. Batch transactions per second in the FIFO is 3,000. Batch transactions per second for high throughput FIFO is 70,000. Right. So basically, this talks about the number of messages that you can push into the queue, or rather, how many will be processed. And the last one is the in-flight messages per queue, which is just 20,000. So at any given point in time, your FIFO queue can only have 20,000 messages in it. It cannot have more than that. Now, imagine for an application of a scale of Conf where we have hundreds of events being hosted and hundreds of organizers using it to launch campaigns. 20,000 probably is a smaller number. So the next option is standard queues, of course. So the first advantage is the in-flight messages is 120,000, 120,000, and this is a limit that can be increased as well if you raise a request case to AWS. So that's a decent number, and I can obviously get it increased as well. Faster to process since there is no order to be maintained. Again, for people who have worked with FIFO queues, you will understand that if there is an order, you have to make sure that each message is processed after another. Whereas in standard queues, there's no order to be maintained. So multiple messages can be processed in parallel as well. And from a cost perspective, standard queues are cheaper than the FIFO queues. So now what do you think? What wins? So standard wins. Although I talked about the various advantages that the FIFO queues bring into picture, we went ahead with standard queues. The reason is, basically the challenges with the standard queue is you have to implement idempotency. So why do we have to implement that? Is because standard queues on AWS do not guarantee just once delivery. So there, it is at least once delivery. So there is a possibility that a message can be delivered twice or more than once. So we have to build for idempotency. And extra processing is required for fetching the campaign status. As I told you, if it is ordered, after the 100th message is processed, I know that it is completed. Whereas in standard queue, there is no order, so I don't know what it is. And but still the standard was standard is what we chose, because FIFO, I told you about duplicates, handling duplicates, right? So that duplicate period is only for 5 minutes. So basically, if a duplicate message comes after 5 minutes, it is not really handled, and it is slower because there's an order. So as I told you, we have to have an architecture that is scalable to hundreds and thousands of messages. So if you have them in ordered for a particular campaign, it can take up to hours as well. The next one is the throttling limits, one of the problems that I mentioned. With SES, or for that matter, any other service provider that you will consume, there are limits, because we cannot overwhelm or just bombard the service provider with so many requests, right? So with SES, there are two such parameters or attributes that you have to keep in mind. One is the daily sending quota, and the next one is the maximum send rate. So what is daily sending quota? Daily sending quota is about the number of emails that I can send in a 24-hour period. That's it, very simple, right? Whereas maximum send rate is basically the number of emails that I can send every second. Okay, so depending on your application's scale, you have to make sure that you increase these limits. Now, how did we conquer this? So now imagine a case where, again, if for people who have worked with serverless, you will understand concurrency, right? So there's something called as reserved concurrency. So before I get into reserved concurrency, let me talk about concurrency for Lambda functions. So the default limit is 1,000 Lambda functions can be executed concurrently in a particular AWS region across your Lambda functions. Okay, now what can I do is, just because I have 100,000 messages coming in, that does not mean that I can have 100,000 Lambda functions coming up and consuming, processing them. That is not practical, because I do not even have so many Lambda functions capacity. So how did we solve that? One is that, and the second one is, how did we make sure that we are not breaching the per day limit or per second, more importantly, the per second limit. So in AWS Lambda functions, there's a feature called as the reserved concurrency. So in reserved concurrency, what happens is you can define for each and every Lambda function how many instances of that Lambda function can come up at any given point in time. So what we did was, we have configured that in saying that even though the SQS, which connects to the Lambda function, has 100,000 messages in it, it does not mean that 100,000 Lambda functions can come up. You only keep so many Lambda functions can come up, so that those many Lambda functions can talk to SES and send the emails. That way, even though my SQS can scale, even though my Lambda functions can scale, my SES account cannot. So therefore, I am limiting. That way, we controlled or we conquered the send rate, which is the number of emails per second, right? So that is about reserved concurrency. The other feature that we consumed of AWS is the maximum concurrency limit of SQS. So what happens is, although I have set the limit at the Lambda function level, there are some disadvantages of doing so. So what happens is, I'm reserving the Lambda functions to only those many, and even if I want to increase them, I cannot, because that's the maximum limit. So what happens is, there's a new feature released on SQS, relatively new, which is basically at the SQS level itself, I can define how many Lambda functions can be triggered from SQS. So that I can say, therefore, I'm not setting or configuring the Lambda function, but rather the funnel of SQS itself, I'm keeping it smaller, so the number of messages that go out of my SQS itself is limited. So that is another way that we have we were able to solve for the send rate, so that SES is not overwhelmed and my Lambda functions are in a limited numbers. The next thing is the scheduling of campaigns. As I talked about, organizers want to send campaigns at any point in time. They don't want to be awake at 1 a.m. in the night, right? They just want to schedule and go to sleep. And the application has to make sure that it goes, right? So the challenges of creating a scheduler is basically, the campaigns can be scheduled to the minute. So as I mentioned, it can be at 1:33 a.m., right? And the scalability of the scheduler service, there could be hundreds and thousands of campaigns that need to be scheduled. So what is a common solution that one would do is, you can write a cron job that probably runs every single minute to see if there are any campaigns that are scheduled at that particular point, and process that campaign. But there are certain, which is what we did, by the way, in the initial stages. But there are certain problems with it. Because you're running it every single minute, it means that you are obviously incurring cost for running the cron job, the Lambda function that is picking it up and trying to process it, even when there are no campaigns to process, right? And it also increases the application complexity, because you have to write cron jobs, and you have to maintain them, and all sorts of things. So that is where another the event bridge comes into picture. Okay, so event bridge, as I talked about, is another service that we have consumed. So what does this bring into the table, and why is it an advantage, right? So Amazon Event Bridge is an event bus service where you can have event buses, you can have rules, you can have consumers, you can have producers, and all sorts of things. This, on a high level, is a diagram that depicts the various features of the event. Event Bridge is a big service. Schedulers are one of it. So what happens is with scheduler, even with scheduler, I can create schedules to the minute. I can create millions of schedules. And the biggest advantage is I can either create it as a recurring job or I can create it as a one-time schedule. That means an organizer is trying to create a campaign, as I said, at 1:33 a.m. So I can create a schedule at 1:33 a.m. and I can say, okay, for this schedule, this is the input. And once with this input, I have to call the Lambda function. And that Lambda function will process the notification campaign, right? So I can create millions of schedules, and it can be one-time schedules as well. It doesn't really have to be a recurring schedule, right? And it can trigger, and it can automatically directly trigger over 260 services, right? You don't even need a Lambda function. You can directly have Event Bridge talk to Lambda, you can talk to step functions, you can talk to S3. As I mentioned, there are 260 plus services that it can talk to, right? And what we can also have is you can have resilient architectures with Event Bridge, because what happens is you can have retries and connect DLQs for all the failure cases as well. And the last important thing, very important, is the time zone support. So basically you can create schedules for different time zones. Again, for a platform like us who serves which serves global audience, time zone becomes an important thing. So I can create a schedule depending on the time and the time zone of the organizer that they are choosing. So, what are the various other challenges that we are still yet to conquer? Is basically the automated end-to-end testing of the entire architecture. Again, for people who know about AWS and the various services that I talked about, you would have understood by now that all of them are asynchronous in nature. So whenever there's asynchronousness in your architecture, it becomes difficult in terms of automate the testing process completely end to end. It can be done, but it is challenging. That is something that we are still working upon. And the next one is observability and monitoring. Again, since there's so many pieces, all of them loosely coupled, it becomes very difficult to kind of debug a problem because there are multiple points of failures. So you have to make sure that you kind of handle all those things and architect around it. And then last one is automatic handling of service provider limits. Like for example, one AWS SES account has one limit, whereas the other SES account has another limit. So how do we take care of that, given that there are so many consumers of the platform, so many organizers? So how do we conquer that? So these are a few things that we are still working on, and some interesting problems. As I mentioned, the last one is certainly very interesting and difficult to solve. So this is something that we are still working on. So yeah, that's pretty much it. I hope I'm right on time. And yeah, thank you so much, everyone, for having me, and especially the organizers for having me. It was great. And this is my LinkedIn and Twitter links. If you guys have any questions, I'll be happy to answer. If not, I'll be more than happy to connect and talk about AWS serverless and software in general.
That was great, Sushrit. I think we do have two questions in
Okay.
the comment section. One was the how does it recover from short burst limit if it exceeds for say 1 hour?
Yeah.
So you want to take up
So
that?
again, as I mentioned, yeah. So as I mentioned, there are multiple places actually. Burst limit, especially when it comes to SES, right? So SES kind of still accepts a sudden burst in request for a short period of time, not extend. Like for example, let's say your sending limit is 100 emails per second, and suddenly you send 120 emails per second. AWS is not really going to throttle it, but it will still let it go for a short period of time. So that is where all the other things like reserved concurrency, the max concurrency at the SQS level comes into picture to make sure you're safeguarding your architecture or your application from bombarding SES and eventually throttling it.
Okay. Okay. Yeah, makes sense. I think this is it then. We are uh, to the your session, and thank you so much for joining in.
Thank you so
Yeah.
much.
Yeah. Thank you. Yeah, so our next speaker will be Muhammad. I'll just add him. Hey, Muhammad.
Hello, am I audible? Clearly?
Uh, you're quite not clear? Can you hear me?
Uh, yes, I can hear you, but can you hear me?
Yeah, your voice is a little feeble, but it's audible. So, okay. So I think the topic that you'll be talking about today will be write your own containers using Go. Am I correct?
Yes, I'm going to talk about that topic. So am I clearly now? Clearly audible now?
Nah, yeah,
I
your
I
voice is
did.
clear. Right.
Okay, perfect.
Okay, the stage is yours. Go ahead. I'll be backstage if you need any help. Right.
Yes, just let me know if anyone can see. You can see my screen. Uh, Give me a moment. Sharing screen. I will show. Okay, you can see my screen, right?
Yeah. Okay.
All right. Thank you very much, Minal. So,
Go ahead.
hello everyone. Hello everyone. Thanks for tuning into my session. I am Mohammed Khanid, and as you might probably know, that we are going to talk about containers. So, not we are not just talking about containers, but we will also be looking at how we basically create your own containers and what are the things that happen under the hood when we are creating our own containers, right? So I'm Mohammad Khanid. I work at security.ai as a Golang engineer, which is basically a data analytics platform company, and they are operating in Pakistan, India, and United States of America. I'm also an AWS community builder, so it's basically a community program for AWS by AWS where we get to network with all of the engineers and to get some perks and stuff. And I also do occasionally write technical content as well. So like these are this like my mini intro. All right, so basically when we talk about containers, so you might think of it as an isolated box where things are happening under the hood irrespective of what's happening outside in your operating system, right? So yes, you are right. In simple layman terminology, we can say that. But if you think about in terms of technically, so container are basically are these four of these things. So whenever we basically create our container, we are actually creating our own process, and in this process they are isolated. By isolated I mean that they are whatever we are doing under the hood or whatever we are doing operations inside our process, it will be doing irrespective of whatever anything happening outside on our OS, right? So also a container basically share resources. So there are some things that I'm going to discuss about, like how we basically able to share resources in containers. So if you ever work with container technologies, so you know that it basically took some of your memory, some of your IO, and some of your RAM and stuff, some of your basically utilization of your operating system, right? So it is also a way to share resources from your operating system. We can also say it as a mini virtualization because it's not actually a virtualization, but you can say that it basically virtualized in a way that you do not use any other big component like hypervisor, which we basically use in virtualization technique, but we basically just create a process which is directly communicating with our operating system. Also, there's one thing when we work with containers internally, so there's called chroot operation. So chroot operation is something that we are going to discuss very briefly in later, but for now it's just something that uh, we basically change the directory of our container whenever we are implementing our own container because of their file system and all sort of stuff. So yeah, so this is what basically like container under the hood. And yeah, so there are some steps when we say that we are going to build our own container. We have to you know think some of the components in our mind. Like the first is namespaces. So namespaces is basically a Linux feature or Linux kernel feature that helps us our container or our process to achieve isolation, right? So obviously, if I'm writing my own container, let's say container engine, and users are going to start their own container using my container engine, their containers, their multiple containers should be isolated until unless we are providing, like, the same networking. So for that to achieve that isolation in our containers, we basically use the Linux namespace features, which we are going to which I am going to show later in via code and via demo as well. So the next component is C group. So C groups also a Linux kernel feature for basically allocating our system resources. So as I like mentioned earlier, that whenever we create containers, it basically shared resources like CPU, memory, file system, IO, and all sort of stuff. So how does it do that? C groups is a component that basically connect your containers or your processes to the resources for your operating system. So it is also an integral feature for working with containers. And basically the third component that we basically use when we are creating our components is chroot. So change root, it stands for change root. It is basically a Unix command that changes the root directory for specific process. As I said that when we like implement our own containers, we are creating our own processes, and that own processes should have their own file system as well, right? So to mount their own file system and to get to their root directory, we have to use chroot, which is basically change root command. It is basically a Unix command that we can use irrespective of any other thing. So basically, the use cases for change root commands, whether we are testing or developing something, like in this case, we will be doing in our container demo. And yeah, so and one more thing here. So in namespaces, there are different kinds of namespaces. So I basically forgot to tell you that we have multiple kinds of namespaces. PID namespaces, which is process ID, MNT, network namespaces, right? So we are going to see that as well, because whenever we like create our own process to achieve to when in an isolated form, we might have to use like PIDs and PID namespaces or MNT, which is mount namespaces or network namespaces for let's say. Okay, so that's pretty much my theories. So let me share the live code and the live demo, which I'm going to show you right now. Okay. Okay, so you can see my editor, and I have already like prepared the structure of my like Go code. So yeah, we are doing all this stuff in Go. So if you are aware of Golang, that is great. You might learn something new. But if you haven't worked with Go, so don't worry. You will get you will get what I'm trying to say. So as a bare bone structure, what do we basically want to achieve? So let's say we are mimicking the Docker behavior. So if you have ever worked with Docker, Docker runs something like this. Docker runs and the image name, right? So if you ever work with Docker, you know that we basically run the Docker command. We provide the run argument and we provide the image name, and then it started a container for in our operating system. So let me not remove this image. So we are trying to mimic this. What we will be doing is that we are going to do this. Go run. So go run main.go. So go run main.go is a way to run your Go program, obviously. And then we basically provide a first argument this, and let's say we want to run bin bash. So this is the example that we are looking through. So if you see this with rather than Docker, we are doing this, and first and second argument we are providing these parameters, these arguments. So the first thing, if you see in my code, is that we have our main function and we are getting our first argument. So we have to like whenever we run our program, our first argument should be run, which will run our parent function, right? And so after whenever we run our Go program, we basically provide our first argument as run, and then it will run a parent function. So in parent function, what are we going to do? So the first thing is we have to do is we have to create we need to implement a command that executing programmatically to um, achieve the to create a process. So first thing first, we need to create a separate process along with along with isolated namespace, which we are going to use as PID or Unix timestamp. So if I let me write this cmd, I'm going to write code it exec dot command. So there's a command method that takes some of the parameters. So for now, let me write now proc self exe. Now this proc self exe is something important that I'm going to tell you in a while. But let me write the command first. So I'm going to tell you that what basically we want to achieve from this command. We need to write this the append. We have to append function. We will create a string of slice, and we need to provide supplement child. And then we had to use os.args to okay. So let me finish this command, then I'm going to tell you what we basically want to achieve. This cmd.stdin os.stdin. Let me copy paste from here. So okay, so we basically prepare our command execution command. So whenever we get our whenever we run our parent function, the first thing it will do is it will print whatever argument that we basically want to execute, and it will shows us the process ID. Now in parent function, the process ID will be the same, that is basically our Golang application. So whenever we run Golang application, it basically run our in its own process, the main function in its own process. So it will return this. But for the execution command, we have provided this. So let me write a separate process, because in these steps we are only actually programmatically provided the commands that we want to run. For standard input, we basically get all of our response as an input on as our terminal as a standard and output, and if there's in case an any error, we will be seeing that. So for the isolated, now we want to make a process, but we also want to make it isolated, right? So for that we had to use cmd.sys proc ctr, and we have to use syscall dot sysproc sys proc actr. So I'm going to tell you what basically are these. So I'm to import this syscall package. Okay, so this syscall package comes with Golang standard pack. Whenever we install Golang in our computers, there are a lot of packages and binaries that comes as a pre-built. So syscall is a package that basically achieves us to call achieve calls with our operating system, or we basically directly communicate our operating system. Either we are doing communication with our kernel or resources, etc., etc. So system proc ACTR is basically, if you see this, it's basically an struct, and it provides some of the basically I would say values that we basically have to use in order to achieve isolation in our component, right? So what I would do is I would add clone flags, and clone flag I would have to syscall dot clone new use Okay, so syscall.clone new UTS is basically Unix time. So whenever we basically create our own process with an isolated manner, we have to get the Unix timestamp of from our host operating system. So this is why we basically use new UTS and syscall dot. We also had to add clone new PID. And as I mentioned earlier, whenever we are creating our own process, it should have its own process ID rather than it's coming anywhere from host operating system. So basically, this this statement of code tells us that okay, we are going to create a process, and it will be isolated. And here and there, we basically handling our error. So whenever we run our command, we it will run perfectly. But in case if there's any error, we basically exit our program. Okay, so as I told that I'm going to tell you about what is this, right? So whenever we talk about processes in Linux specifically, because I'm showing you demo in Linux, so there is a directory called proc, which basically contains all of your processes in your of your operating system. So by providing this, we are what we are trying to tell our program is that okay, run this parent function, but again execute re-execute this child function. And if you see this case, whenever we append the child argument, it will run our child function. So the thing is why basically we want to run child function, because is whenever we are creating process, so creating a process and making it isolated is a separate thing. And to do setting our host names and to achieve and to communicate with C groups and their resources with the host operating system, that itself happening is other process. So this is why I basically created a child function. So I have already like prepared the command. So if you see like child function, what we basically are we are printing os dot argument. So basically again that same argument will be printed on standard output. And on this get PID, we are going to see our isolated process PID. Now, again, I'm mentioning this again. Whenever we run our parent function, it will get the PID of our Golang application, which is running on host operating system. But when we run our child function gets executed, the PID we will be getting is from our isolated process, which will be one. And I'm going to show you that in a moment when we run this program. Okay, so we already have set up another thing. We basically have to add exec.command again, so we could we could basically execute command for our child argument, so that it runs this function. So it basically runs in a parent function and again iteratively runs as a child function. Okay, so if I show you my terminal. So right now I am in sudo mode, and this is like the Linux terminal. Currently I'm in a project directory, and so yeah, in my above like the first one, I'm going to show you like when we basically create our own processes. How does it look like? And in the below one, I'll be showing you like the what basically host operating system processes looks like. So if we basically see the host operating system processes, so if I do this, so these are like the processes that currently running in our operating system, host operating system, right? So if let me do this call dot this call dot what I can do, we have to use ch root. Okay, so when we create our isolated process, we have to we have to change our root in order to tell our process okay that we have to operate from that file system, right? The basically change root directory. So what I'm going to do is ch root. Yeah, we have ch root function. We provide a path, and I'm going to provide a path as a single slash, which is basically my home directory. Also, what I'm going to do is I need to add syscall.ch directory. So Change directory. So whenever we basically change root, we also have to change directory. So why do we need this? Whenever we basically uh, um, up and run our container, we have to make sure that whenever we created our own process, it should be in the root. It should be in the specific directory, which is also a root. So it will be in my container root directory. Right. So these two are the things that I have to run, and also we have to cmd.run function. uh, let me do it in must. So if there's in case is any error, we can basically catch it right in front of must function. Must basically is just a helper function which I just wrote below, and you can see it's just responsible for catching the errors. Okay. So these, so what we have done right now in programmatically, we have set up our execution command. We have basic iteratively set up to run parent function and then into function. We then again have created namespace for achieving isolation, having Unix time and process ID, and we also added chroot and ch directory to get directly into our home directory whenever we run our container. So let me save this and let me go into not this. That was a funny image by the way. So what we have decided, we have go run main dot go. The first argument would be run. The second argument would be bash because we want to be in our bin bash. So bash is basically a terminal that where we basically run our Unix command basically, right? Okay. So as you can see, this is running from our parent function, which basically shows us the process ID, which is of Go length, and you also can see that it is running from our child function, and it has a process ID of 1, which means that we basically created our own process. So if I show you this, so you can see 25712, right? So 25712, it is your main basically program, right? So but you might be wondering, okay, why we are not seeing the processes in PS1? So so the PS command, the Unix PS command basically directly does not see onto your processes. So there is a thing. If I show you ls proc, lsa proc, so you can see there's a directory in Unix operating system called proc, and all of your processes are basically creating and deleting from here, right? So this is not our basically not our container processes, but this is basically our host processes. So how do we basically achieve that we whenever we create our own container, we have our own processes, own, and whenever we basically run our PS, it shows the processes that are running into our container, not the host operating system. So for that, we have to mount our file system. And to mounting the file system, how we can achieve this? Okay, let me show you via code. Okay, Hmm, it's working a bit slow. Okay, so the first thing we can do here is not here. In fact, we have to run it must. We also have to syscall because it's a system call to mount a folder, and we are going to mount. Okay, so what folder do we basically want to mount? So right now I don't have basically a separate copy of my file system, which I can show you. But whenever we are working in production, we do have separate basically copies of file system that we basically mount, and then the container that we are going to create is directly like starting in that file system. So right now I'm going to show you with my Linux file system. So let me go. I am going to add proc because my all processes contain in my proc folder, which I already showed you. We have a target which is also proc, and we can fs file system type. It is also a process type. And what do we have to provide? We have to provide a flex. We can provide 0 here, and data, we do not have any data, so right now we can leave it as empty. So now what this command does do is basically create a file system. So you basically create a file system named proc, and all the things that in proc folder has, which is basically in our root directory. Proc is always in root directory in Unix, right? So when we basically mount our proc folder, we create our own file system for our container. So let me show you how does it look like, and I'm going to show you how does ps command like look like in that process. So why does it not moving? Okay, I'm going to okay, so go run main.go, run first argument. We have to run bin bash command. So when we run this, so if you notice that first we are having our host name. If you could see this line, we are having our host name like this, like ThinkPad T4 T540, which is my computer name, right? And again we are seeing that okay, so we are seeing that we have host name T540. So we can also programmatically change our host name. But first things first, if we see our PS, now you can see that our PS showing uh, only those processes that is running into our container, right? We are not we will be not able to see the host operating system processes because we already mount that for our container, right? So if I try to do this, you will always get the same. And if I do ps command into my host operating system, not in container, you will see that it's getting an error. It means I have to unmount this process folder until unless this proc folder is dedicated to my container. And that's how basically you mount your folders um, for your containers. So this is basically whenever we say when we are creating containers, these are the things basically doing under the hood. Now there are a lot of things that we can do. We also can configure C groups, and we can achieve multiple kind of security as well. But obviously I cannot show all this stuff there because of the time constraint. So one last thing that I would like to show you is how can I change my host name. So syscall dot set host name. So this is a function. Whatever we basically provide, it will change the host name. So what does it? We can understand. Okay, so we have to provide a slice of byte for there. That's basically a syntactical error that I was doing. So basically, we can also change our host name, uh, which is basically this, which is basically called this. So right now, I have to unmount, you mount PROC, okay, and oh god, it's already getting hanged. Let me again show you how we can change the hostname. So I run this command. Okay, so there's some error that I'm getting, but you get the idea how basically we can change the hostname. Hostname basically is this part, and whenever if you have ever worked with containers, you might have noticed that whenever we bin bash into a container, it changes the hostname as well. Right, so that's like the pretty much it from my live demo, and these are the resources that you can follow. You can follow me on GitHub, and I will share my GitHub repo in a while, so you can also see the live code that basically I put here, and you can play all along with it. So thank you everyone. Thank you for having me. And I know I am a bit over time, but
That's completely fine. Hope that was really nice talk, Mama. Thank you for your time. Uh,
right. So do I have to stay a while?
yeah,
Okay, okay, fine.
yeah, backstage if you can stay. Yeah. So our next speaker will be Sophia. I'll just be adding her on the stage. Hey, hi Sophia.
Hi guys.
How you doing?
Hi. I'm doing fine, thank you. I hope you
Okay,
can
I
hear me very well.
yeah, you're very much audible. Yeah.
Awesome.
So I see that you will be talking on securing your Django applications for and the best practices that are to be followed. Am I right?
Yeah, I think that
Okay,
is
go ahead. The screen is yours. I'll be backstage if you need any help. Yeah.
awesome. Let me present. Let me share my screen and present my slides. All right. Can you see my slides well? All right, so I think you can. So hi everyone. I am Sophia Eribu, and I'm here to talk about best practices for securing your Django application. Now, my talk is going to be focused on practices to implement authentication, authorization, and protecting your your Django project or application against common web vulnerabilities. So before we start, a little bit about myself. I am Sophia Eribu. I'm a developer advocate. I currently lead the GDSC and the MLSC team, the MLSA community in my school, and I love Python and I enjoy writing technical articles. So let's get started. So why should you care about web security as a developer? But first of all, you should care about that because you are supposed to safeguard your user data. So when you implement a secure security measure in your project or your application, you can protect sensitive information like your user password, their private information, their financial data, and lots more. Another reason is that when you care about the security of your project, you get to build and maintain an integrity or reputation around your project. So by building and deploying a secure project or a secure application, it can help you maintain that user trust when they want to use or when they want to tell people about your project. Last but not the least, complying to regulation. So adhering to industry legal requirements would make it easy for you to avoid any lawsuits in the future or any legal consequences. Now let's talk about two most exploited Django vulnerability. First of all, we have user inputs. So from user inputs, we can have some attacks like the SQL injection attacks, cross-site scripting, and some other attacks. Now, how can a cyber attacker attack your Django project through user inputs? So they do this when you do not properly sanitize or properly validate your user inputs. And another one is authentication and session management. When your project has like a weak authentication process or session management, it leaves your app vulnerable for attacks like brute force attack, session fixation, and cross-site request forgery. Now, here are the common security mistakes that I have made and I've seen in a lot of Django projects. First off, failing to use the HTTPS when sending data from client side to server side. When you fail to do this, you leave that data that moves from the client side to the server side vulnerable for attacks. Another one is storing password in plain text. When I started as a Django developer, I thought that you are supposed to save the user password as the imputed is. For example, if the user's password is password 123, I thought that you were supposed to save that in your server or database as password 123. But that is very bad if you do that. Another one is leaving the debug setting enabled in production. Now, this debug setting is there to help you as the developer, to help you debug and catch issues before you deploy your project. So enabling that this setting to production will just leave your application vulnerable for any cyber attacker to know a bug that they can use to penetrate your server or your application. Another one is revealing sensitive information in error messages. So I've come across some projects where in the error messages they included the user password. I'm not sure if that was a joke or that was intentional, but revealing such sensitive information in the error messages just makes it a whole lot easier for the cyber attacker to gain access to your server. Another thing is failing to implement proper access control. Now, when you fail to give uh, setting control to certain users, like you have an application and a user can access every single thing about your server, about your application or your project. It makes it easy for anyone to just create an account and have access to your database. Another one here is adding sensitive data like your API key, your secret key, your private key directly into your code. Now, for Django developers, it's um, important that you add this sensitive information to a .env file within your project, and then you can use the python.env to call that key to the file, to your Python file that you want to use it. That way you can protect adding these keys to your code directly. Another one is not implementing a two-factor authentication. In as much as you have a secure authentication process, having an extra layer of authentication makes it more secure and makes your users feel happy using your project or your application or your software. So how can we resolve these common mistakes? Let's talk about best practices on how we can resolve authentication and authorization security. Number one, on the authentication, implement a secure or a robust user authentication, like use JWT token-based authentication to authenticate your user. That way, it's more secure for your user to use your project, and add a two or multiple factor authentication so that your user gets to verify themselves twice, and you can catch any small error or issue on the authentication aspect. Then let's talk about the authorization. So I made mention of um, okay, we'll talk about that later. So under the authorization, ensure that you use a secure password hashing algorithm. So when your user's password is let's say car 123, don't just take that car 123 and add it to your database. Hash it. add some random data, some random character to ensure that the password is secure even in your database. Another one is session management. So when you are dealing with JWT, this is a mistake that I make often. When you are dealing with JWT or token or could be token or cookie sessions, ensure that you have an expiration time for when that token or session is going to end. That way, your user will not have multiple, will not send requests to your project on multiple devices at once. Then let's talk about role-based access control. Ensure that your projects have at least two user roles, the admin and the regular user. And then ensure that the regular user cannot just access any information. Ensure that that user can access just a specific information or a specific data. That way, you will not have any user just creating account on your project and gaining access to all the data and information on your project. And this is very, very important, especially if you are building an open source project. Now let's talk about some ways on how to securely hash a password. First off, use a secure hashing algorithm. In Python, we have the Argon2, Bicrypt, Skycrypt, and lots more. So ensure that you use an algorithm or a function to add data or to sort that password. That takes us to sorting. Now, to sort or sorting is when you add random data to that piece of information to strengthen or to secure the hashing process. So when you take that car 123 and you add random data to it, like you add 1 2 plus comma abbreviation lots more so you take the user data and the random data, you mash it up and you save that in your database or server. That just means that you have hashed it and it will be more secure as a hashed data than an unhashed data. Now let's talk about protecting against SQL injection. When you are using Django or Django ORM, Django ORM stands for Object Relational Mapping. Django ORM has what we call the parameterized query. So what this query does is that it separates the SQL code from the user generated data. Like you are taking an input from the client side. The Django ORM works in a way that it removes the SQL commands from it, like the user can decide to play a trick by adding an SQL command, like select star whatever, and your Django ORM would remove that SQL command and see that input as just a normal user data and use it to query your database. When it does this, it prevents any server attack that the user would want to do. Then let's talk about protecting against cross-site scripting. So cross-site scripting is cross-site scripting attacks or XSS attacks are attacks that inject malicious scripts into the web pages accessed by other users. So in the keynote talk for today's session, Martina talked more about cross-site scripting, CROSF and CSP, that's content security policy. So if you want to learn more about that, I would highly encourage you to watch that keynote session. So the first way for you to protect against such attacks, ensure that you use a validation to always validate your user input. Don't think that your user is very smart, that they would pass or send in the data that you want. Ensure that you validate it. And in Django, you can use the built-in validation. So the Django plus call plus validators. This validates the user input. Like in this code snippet, it checks if um the user input is actually a valid email address. So using such tools would really help you in terms of input validation. Another one is output encoding. When you are building, sorry, when you are building a project that needs you to take user data and display it on your application or display it on your web page, ensure that you use the Django auto escaping template. So this would take that user data, encode it, and pass it as a plain the data text on your web page. Next, HTTP headers. Always ensure that you use the correct or the appropriate HTTP headers to prevent any to prevent your browsers from interpreting your content as a script. I mentioned two HTTP headers that you can use. The first one is this X hyphen content hyphen type hyphen option say semicolon no snip. So what this header does is it prevents the browser from guessing the MIME type response. Then another one that you can use is defining the content type and ensuring that it is encoded. So you can use this script to ensure that your content is treated as a HTML if you are dealing with a HTML file. If you want to display it as an XML, you can still decide to change this to XML. So what this script does is that it treats your content on your web page as the file type that you define and encode it properly to avoid any form of attack. Another one is the content security policy. Always and always implement a content security policy to restrict sources from which resources can be loaded to on your page. What this means is that you can set like a security barrier on your web page to ensure that only trusted resources are being loaded on your web application or web page. This should stop any form of XSS attacks or cross-site scripting attacks. Next up, let's look at how to protect against cross-site request forgery attack. So this type of attack will trick your users into performing any type of action without your user knowing that they're actually doing that. So the first tip that I will give you to protect against such attack is using rates is creating a custom middleware that limits the request based on your client's IP address. So what that middleware is going to do is, if you have user A that decides to attack your web page or your website using multiple devices, creating a custom middleware that tracks and blocks that request is needed, because user A or user one cannot send a request from device one, device two, device three, and device four, and all four of them would be accepted at the same time, because you would need to limit the user request based on their IP address. Then another thing is, if you cannot create, your own custom made middleware, you can decide to use the Django CSRF middleware that does the same thing I just explained. Another thing is using the CSRF tokens on your Django template. So if your project involves you to use a HTML form, having such tokens, that's this token right here, having this token on your Django project would also limit the request based on the user's IP address. Just some tips on how to securely handle sensitive data. In as much as you would have a robust a robust authentication. Always ensure that every data that your user sends to you, or every communication from the client side to the server side, is encrypted. That way, it will be harder for your data to be attacked. Then, as I said earlier, ensure that you implement a secure access control. Last but not the least, this is something that I tell people a lot. Ensure that you back up your data at least every three months. So if there is eventually an attack on your database or your server, you can easily recover those sensitive information and reduce data loss in your project. Now, this is a command that I recently stumbled on. This command is like a Django security checklist. So what this does is that when you are ready to deploy your projects on Azure, AWS, or Heroku, or any place, when you run this command, it checks your settings.py file and ensures that you have passed the Django security guideline. So this is a screenshot from a project that I'm currently working on, that I'm not ready to deploy yet, but it caught some of the warnings that I needed to address. For example, I needed to set my debug to false. I needed to add URLs to allowed host. I needed to add a secure SSL redirect. I needed to, set my session cookie to through, and lots more. So with this, it will be easy for you to have a checklist of security measures that you need to do, or security measures that you need to check off your checklist before you push your project online. Still, some tips on, building a secure Django project. Number one is monitoring security activities on your project. So you can decide to set up a monitoring means where it checks your deployed Django apps and detects any vulnerability that will be that can be exploited or that has already been exploited. An application that I would recommend in terms of this would be Git Secure. That's GIT, then Secure. That is a project that every time I push a code, be it a private repo or a public repo, it ensures that I don't, expose my private key. It ensures that that project is secure. Then another thing is regularly update your Django frameworks, your dependency, your libraries. If you currently have a deployed project that users are using, I would advise you every 3 months run a general update on the libraries and packages that you use. Why? Because with each update or whenever there is a new or latest um, update on that library or package, it comes with bug fix and security patches that cannot be easily exploited. So when you update this stuff, it helps prevent any attacks in the future. Last but not the least is implementing logging. So I know that on Azure, when you deploy your project to Azure, they have a login feature that lets you monitor your project and detect any potential security incident when the user is using it. So to wrap this talk up, building a Django project or being a developer goes beyond just building that tool that can solve a problem, or building that tool that people love, but you also need to take preventive measures, because that tool that people love can easily be exploited if you fail to address such security measures, if you don't implement a secure or authentication process, or you don't update your packages, or you don't have a rate limiting within your project. So please ensure that your project is not just useful for people to use, but also secure as well. Thank you. So if you have any question that you cannot ask on the live chat, you can reach out to me on LinkedIn or Twitter.
All right. Thank you so much for your time, Sophia. That was a really good talk, really very informative. Yeah, looking forward to connecting you over your socials.
All right. Thank you very much. Bye, guys.
Bye. All right. So our next speaker will be Mohammed. I'll just be adding him on stage.
Hello.
Hi. Hi, Mohammed. How are you doing?
Good. How are you?
Good. I'm good. I'm good. So I see you will be talking on how like creating your CV using GitHub plus actions and latex, I think, right? Am I right?
Yes. Exactly. Yes.
All right. The stage is yours. You can start presenting. I'll be backstage if you need any help, right?
Thanks a lot. So let's
Uh,
share a screen. Okay. So is my screen showing now? Yes. Nice. So let's get started. This is my talk. Create your CV using GitHub and LaTeX, basically. So that's me, Mohammed Ali Arabi. I'm a software engineer at Haufe. That's the company that I work at, and that's in Freiburg, Germany, right in the corner, uh, near the borders of France and Switzerland. And I'm a Docker captain, basically writing blogs and uh, talking in events. Okay, and yeah, also these are my handles on GitHub, Medium, LinkedIn, Telegram. That's my handle. That's my basically my last name. And on Twitter, this is my handle because the other one was already taken. So my My handle is Muhammad Ali EN because that's my English-speaking Twitter account. But some people also mentioned that it reads Muhammad Alien. So yeah, so that might be the truth. This is also me, we organize meetups with the community that we have here. And with that, let's jump right into the talk. This is going to be 3 parts. One is about using text-based formats for documents in general. So why should we use something like LaTeX or Markdown? History, you want to have a history of your document, basically. And the last point is automation. We will jump into each one of these topics one by one and see why do we want to get there. Text. So what is the worst format to use for your CV? That is Word. So why is that? A few reasons, actually. For one, Word is ugly, so the output is not really nice. But actually, the most annoying thing about Word is that you edit the thing that you're writing. So you see the rendered version of the things that you're creating. And that's usually not very reproducible. So this is usually what happens. You change one thing, one pixel, and everything is ruined. And usually it's not easy to fix. If it's ruined, then it's ruined forever. The main reason is that you can't really see what's the source of truth for your document. This is why I would say it's always better to have a text-based format and then render it into something that you want. Like you have Markdown that you can write things in, and then you can format them and render them into PDF, for example. Or if you want to have a more complicated document like a CV, which is probably the most important document that you want to maintain, then LaTeX is basically your friend. So one reason is that if you have a text-based document, you can have versioning on it. So in the case of Word, it's a binary format. If you want to see what has changed from the last version, there is gibberish, basically. So you can't see, okay, I added this line here because it's not human readable. If you open a Word document using Notebook or Vim or some text editor, you can't see anything in there. So it's all binary data. And if you want to use diff tools on the Word document, then it's meaningless. This is why it's nice to have a text-based document, and then you can use Git, for example, to have versioning on your document, and then you can go back in time. The second nice thing about LaTeX is that it's modular. You can you can use basically other people's work. You can download some libraries into your document and use them easily, because that's how it works. And yeah, this is why LaTeX is usually recommended to use for a CV. There are a lot of very nice LaTeX basically templates for CVs. You can look them up online, and then you have all sorts of different CV styles. You can go there, then the template is there. Everything is abstracted away from the content of the CV, and you can go there and replace the content of the CV without needing to worry about how it would look like. And also, the output is really high quality output. So LaTeX was really created in the first place because the creator, which was a software engineer at the time, wanted to write a book on software engineering, and he wasn't satisfied with the quality of the tools that were available at the time. So he created LaTeX and then wrote his book in LaTeX. So this is basically one of the promises of LaTeX, that your output looks good, and all the default fonts look really awesome, and you can really see the difference if you compile your CV using LaTeX, and then if you compare it to Word CV, then you can already see the quality difference. Okay, history. That is one of the other things that we also talked about. When you have a LaTeX CV, then you can put it on GitHub, and then every time you change something, then you can commit it using Git, and then you see, okay, I had this change in here, and then if I want, I can go back in time and then load the CV version that I had 2 months ago. You can have different branches on your GitHub repository, for example, and have one CV tailored for this kind of position. I don't know, if I want to apply for both Python and Java positions, then I can have 2 different branches for each one of these different versions of my CV. And the most important part is that when you have text-based document on GitHub, then you can automate a lot of things. Because this is the tooling that is used for codes, and because engineers are working with these tools every day, a lot of ecosystem is built around it. And then you can leverage these tools to basically automate a lot of things about your CV. This is an overview of how this whole thing would work. You have a LaTeX CV that is probably on Overleaf. Overleaf is a very popular platform that you can use to edit your LaTeX files and compile them. They also have a lot of very nice templates for CVs. You can look them up. Then you have a GitHub repo that has the exact same project. Overleaf has the ability to integrate to a GitHub repo, and then every time you have a change on your CV on Overleaf, you can basically commit it to your GitHub repository, and then it's automatically pushed. Then you want to have CI/CD pipelines on GitHub, so that every time you have an event, for example, you can do it on push, or you can do it on tags. We will look into that later. These CI/CD pipelines are triggered, and then they compile your CV. Why is that important? Because then you can have artifacts on your generated on your CI/CD pipelines, and then you can store them on GitHub. And if you go to the GitHub repo, then all the artifacts are there, and then you can have all the versions of your CV in one place. Let's take a look at what we are talking about here. Okay, so the CV that I have, I called it Hacktoberfest CV. If you look it up online, this is the first one. You can open it, and it goes to my GitHub repo. There is a lot of README instructions here, so that you can follow them to set it up on your own, and you can basically fork this repo and then use it for your own CV. And here there is the workflow that we have. So it's just one job, simple. It basically sets up the Git repository. It checks out your code into the environment there, using the compile the LaTeX action, it compiles the LaTeX, and then you can set output basically, which I called main here, and then in the later job you can release it basically to an artifact. So if I go there, it basically compiles on push, but only publishes as an artifact if there is basically git tag. So we have 8 tags. These are the versions of the CV that I have. And then if we go to the releases, you have the PDF here and you have the source files. If we go back to the repository, I also have created these very nice badges in here. And then the first one is the link to the latest artifact. So if you go there and you click on it, then the latest version of the CV is downloaded. You can basically give it to someone who wants to have the latest version of your CV at all times. So this is always the latest. And then you can basically see the history of everything that has happened on your CV and go back and forth in time or download older versions of your CV. You can also fork this repo if you like. You can improve it. You can, if you like, change the README to make it more readable and more smooth. And then if you want, there are some links to the video of the same talk that we had. I will, after this talk is available, I will put the link of this talk as well in here so that you have access to everything. And that's basically it. We did this basically only for a CV, but using the same method, you can basically automate pretty much every kind of document. So if you have recurring documents that you have to generate every once in a while, I don't know, things that happen every month and you want to compile them, you can also, using the same method, put them on a GitHub repo and use CI/CD pipelines to build them and make them available as an artifact and basically take away some manual work. That was it. And if you have any questions, you can always reach me in on LinkedIn, on Twitter, and yeah, I would be happy to answer your questions.
All right. Okay, I don't see any questions as of now, I think. That was very interesting talk, by the way, Mohammed.
Thank you. I hope
Yeah.
it was helpful.
Yeah. Yeah.
And yeah, so
I mean,
also,
topics
yeah,
about
go ahead.
CV making are always helpful. So,
Yeah, you can also
yeah.
maybe use this template also as an inspiration for
Yeah.
some changes. Nice.
Oh, that's great. That's great.
Then thanks a lot, and
All right.
hope you have the nice
Yeah.
rest of the
Thank
day.
you.
Thank you.
Yeah. Thank you. All right. In the meantime, I think we'll be having a break. See you in the second half. Thank you.